Hello online viewers, welcome to our lecture video. In this lecture video, we'll be talking about hydration of cement. What is hydration of cement? What are the factors affecting hydration of cement? What is the water requirement for hydration of cement? And what are the possibility for not 100% hydration of cement? We'll be talking about all of them. So let's just jump in the lecture video. So first we'll be talking about hydration of cement. What is hydration of cement? As you can see from the name, hydration and cement. Hydration refers to water and cement and cement and hydration refers to water, and hydration of cement in combined refers to reaction of water with cement. It is not any simple reaction. It is a chemical reaction, which is an exothermic reaction. So let's just talk about it. So what does cement refer to? As we talked in our previous video, cement basically consists of four chemical constituents: C3S, C2S, C3A, C4F. They're basically known as box compound, and if you want to know more about them and if you want to know detail about them, I have already created a lecture video about different constituents of cement, which you can which description you can find at the end of the which description you can find at the end of the which description you can find at the end of the video, or in the which link you can find at the description box, or you can find at the end of the video. So firstly, so we're talking about hydration of cement, and hydration of cement basically refers to reaction of C3S, C2S, C3A, C4F constituents of cements with water. As to they react with water, and this reaction is known as hydration. This reaction is known as hydration, and the end product of this hydration is CSH gel, CSS gel plus calcium hydroxide. CSS gel refers to calcium silicate hydrate, calcium silicate hydrate gel, CSS gel, calcium silicate hydrate gel. And this solid gel mass, it is solid gel mass. It is very important for the strength of cement, because the strength of cement is produced or obtained from CSS, from the amount of CSS gel only, and CO as a whole 2 is responsible for corrosion attack. It has to prevent corrosion attack on the cement. So basically, we talk about what is hydration of cement. Reaction of cement constituents with water is known as hydration of cement, and when the reaction is complete, at the end of hydration, or heat is evolved, or heat is evolved, and this amount of and the amount of heat liberated is expressed in terms of calorie per gram or joule per gram, and this heat liberated is known as heat of hydration. Higher the heat of hydration, quicker the reaction is. So the C3S, C2S, C3S, so the C3S has heat of hydration of about 502 joule per gram. Similarly, C2S has about 251, and other have different heat of hydration, and I've already talked about the heat of hydration of all these compounds in my previous lecture video. You can definitely check it out for more. We can definitely check it out for more information. So now let's talk more about hydration of cement. So basically, what happens in hydration of cement is Portland cement gets cementatious. Portland cement or any other cement gets cementatious when it gets mixed with water. So basically, what happens in the microstructure of cement is, let's take this as cement pores. So these are cement pores. Let's say if I add water to this, what happens is it gets cementatious, or it gets crystalline structure of cement gets formed. So these are cement. These are the cement particles. Whenever I add water to it, it becomes crystalline in nature. It becomes crystalline in nature, and in micro level, such kind of structure is formed. And so this cement particle, when water is added, turns into such a crystalline structure of form, and in all these holes, as you can see, and in all these holes, aggregate and sand are binded, and the strength of cement increases, and cement gains is strength, so basically better hydration. So basically, better hydration means better form of crystalline structure or better formation of gel, which means higher bond, and greater strength of the cement, and greater strength of the and basically means greater strength of the cement. Basically means greater strength of the cement. So basically we have talked about hydration of cement. What is hydration of cement? What is hydration of cement in a microstructure? Next we'll be talking about next we'll be talking about the factors affecting the hydration of cement. So one of the major factor affecting the hydration of cement is fineness of cement. Fineness of cement. So how does the fineness of cement affect the hydration of cement? So the first and foremost thing is hydration of the reaction between water and cement. The reaction between water and cement, it starts on the surface area of cement. It starts on the surface area. It starts on the surface area of cement particles. It starts on the surface area of cement particles. So higher is the surface area. So higher or more is the surface area. More or faster is the reaction. More or faster is the reaction. So more or faster is the reaction slash hydration. As we know, finer particle have more surface area. So they definitely have higher hydration speed. Have higher hydration speed, and they have high heat of hydration. They have high heat of hydration, whereas coarser particles, COARS, coarser particle have less surface area, which means less area for the reaction to occur between water and cement. Less area for the reaction of less area for reaction of water and cement, which means hydration process is also slow, and which means less heat of hydration. So as we talked in our previous video, high heat of hydration means early strength, whereas less heat of hydration means ultimate strength or late strength. So basically, a bag of cement consists of both finer and coarser particles. It consists of mix of both finer and coarser particles, because if we just use a finer particle, we'll have high early strength. We have a high early strength, no ultimate strength, and this also gives possibility of shrinkage cracks. Whereas if we just use coarser particle, there will be no any early strength. There will be no any early strength will be obtained. So basically, cement contains a mix of both finer and coarser particle. Next factor affecting the next factor affecting the hydration of cement is temperature. So basically, how temperature affects the hydration of cement is higher is the temperature. The hydration of cement is also faster. That means the reaction is faster. More the temperature, more the hydration. Simply. So less the hydration, so less the temperature, less is the hydration, or less is the chemical reaction, and slower is the reaction. So definitely, as you can see, as the temperature is higher, it pushes the reaction to the left hand side. More formation of CSS gel, more hydration, or more the reaction, more the reaction, earlier the strength is obtained, higher is the heat of hydration. So now next will be talking about water requirements for hydration process. So what is the water requirement for hydration process? As we talked in our last video, the major component of cement is basically C3S and C2S. Basically, C3S, tricalcium silicate and dicalcium silicate, are the major component of cement. So the water requirement of C3S and C2S is the water requirement for the hydration. Water requirements for hydration of cement. So basically, how much water is required for hydration of C3S and C2S is the water required for the hydration of cement. So basically, for C3S, about 24% of water by weight of cement is required, while for C2S about 21% of water about 21% of water by weight of cement. This is both by weight of cement is required for total hydration. So in average we take about 23% of water, 23% of water by weight of cement. So about 23% of water by weight of cement is required for chemical reaction. This is required for just chemical reaction. This is just required for the chemical. This is required for hydration process. About 23%. We have taken average of 24 and 21, which comes to about 23% of water, and this amount of water required, and this 23% of water required. This amount of water required is known as bound water. This much amount of water is known as bound water. But while preparing any cement mix, we don't add just 23%. We add a little bit more amount of water because of the fact that the formation of CSS gel. So the end product which we obtain, CSS gel, calcium silicate gel, it is not completely solid. It has some amount of gel pores in it. It has some amount of gel pores on it, and of course cement. And of course the hydrated product of cement is not completely solid. It has some gel particles, some gel voids. So it has some gel voids, plus it has some air voids. It has some air voids and other form of voids as well. So this voids also needs to be filled for complete hydration, and in order for filling this void, about 15% of water is added. 15% of extra water. 23% is added for hydration of C3S and C2S, and about 15% of water is required for filling of the voids. So in total 38% of water by weight of cement, or rounding this off, it is about 40%, or 0.4 amount of water is required by the weight of the cement. So we call this 23% of water as bound water, is known as bound water, while this 15% is known as gel water. Is gel water, and bound water and gel water both are complementary to each other. These both are complementary to each other, because if the water is inadequate, let's say if the water is inadequate to fill up the gel pores, so is inadequate to fill up the gel pores, the formation of gel will itself stop. So basically, let's say if I add about just 22% of water, about 21% of water, the formation of gel itself will stop. There will be no formation of gel. So there is no any question of formation of any gel pores. There is no any formation of gel pores. So we can definitely see so once the formation of gel stops, there is no question about formation of gel pores. So therefore we can say both the bound water and gel water are complementary to each other. So in total about 40% of water is added, but no any extra water is added. No any extra water more than 40% is added, because more the water we add, there is more chances of formation of voids and more chances of cracks. So basically we have compared what is hydration of cement, what is the water requirement for hydration of cement, and at last we'll be talking about reasons or possibility for stopping of possibility. This is right our topic, possibility or reasons for stopping of hydration process. So of course hydration process is a long process. It continues as long as the water is being added to the cement for nearly about 28 days until its curing period. So but due to certain factor, although the water is being added, the hydration process may stop. So what are the reasons? First reason is shortage of water. Just now I have basically explained the percentage of water required. So 40% of water by weight of cement is required for any hydration process. But let's say if I just add about 20% or anything less than 40%, then the hydration process cannot continue smoothly, and ultimately the hydration process gets stopped. And second process is complete hydration. complete hydration. Let's say after a certain amount of days the hydration process gets completed, and there is formation of enough calcium silicate gel, CSS gel. So at that point, when the hydration has been completely fulfilled, completely done, the hydration process ultimately stops. And the final reason is when and the final reason is, let me explain the final reason. Let's say this is a cement particle. Let's say this is a cement particle. This is the core of cement particle. This is a cement particle. This is a cement particle. I am adding water to this cement particle. So what happens is, the water retains on its surface. It weights its surface area of the cement, but the water does not reach the core of the cement. Let's say the water does not reach the center of the cement particle or the core of the cement particle. So just to the portion. So let's say the cement particle has just reached up to this portion. Cement particle has just reached up to this portion. It hasn't reached the core of the cement particle. Water is added to the cement particle, but the water does not reach the core of the cement particle due to certain reasons. Water just remains at the outside of the cement particle. So just the outside portion, this blue portion, just gets hydrated, while the inner core portion or the center portion of the cement, this portion where the water hasn't reached, remains unhydrated. So as the water does not reach the center of the cement particle, in certain conditions the water doesn't reach the center of the cement particle. In such cases also, the hydration process of cement cannot continue properly. The hydration process just continues up to the area where the water reaches, not up to the core portion. So basically, I have explained the three possible reasons why the hydration process may stop. So as our all other previous videos, if you need the PDF lecture notes, you can check my Instagram page, which link I'll be mentioning in the description box. So if you have any queries regarding this particular topic, do comment down. So if you like the video, if you learned anything from the video, if the video was of any help, do like, subscribe the channel, and if you have subscribed the channel, share it with your friends, and do check out the playlist of cement for complete tutorial, for complete knowledge. Thank you now.